Hello everyone, welcome back to my channel. Today we'll be solving AA Math SL Paper 2 of May 2024 attempt. So let's begin with the first question. So here basically we have a comparison between the lengths of the rabbit's ears in Australia and in Spain, right? So yeah, so there is a test, and here we can see this box and whisker diagram, right? So moving on to the first question, we have to complete the following table for the recorded values of the lengths and the rabbit ears in each example. So Australia, they have given the median and IQR, and here this box and whisker diagram is for the Spanish sample, right? So how would we find the median? Median is basically the value corresponding to the middle line, right? So this is 72 and this is 76. So this value will be 74, right? So, and the red line which I drew, it's in between 74 and 76. So this is definitely 75. So the median of Spain would be 75, and IQR is basically the difference between the third quartile and the first quartile. So IQR would be in this case 84 minus 68, which is 16. Now moving on to the next part. So justifying your answers, compare the distribution for lengths of rabbit ears in Australia and Spain using the median and the IQR. Alright. So here we can see that the median length in Australia is greater than that of Spain, right? So using this as median is a central tendency, so we can say that the ear lengths of rabbits in Australia would be longer than the rabbits in Spain. So the first part, we can frame the answer in this way. For Australia, median length of ears is 80 millimeters. For Spain, median length of ears is 75 millimeters. The median is a measure of central tendency. We can say that the typical ear length of rabbits in Australia is longer than in Spain. Now the next part. So we have to again compare the distributions using the IQR. Now here clearly IQR of Australia is less than that of Spain. Now if the interquartile range is greater for Spain, it means basically the length of rabbit ears in Spain are more variable than that of Australia, right? So we can answer in this way. The IQR is 11 millimeters, and for Spain the IQR is 16 millimeters. We can say IQR measures the spread in the middle 50% data. A larger IQR indicates more variability. Hence, length of rabbit ears in Spain are more variable than in Australia. So that's the end of the first question. We can move on to the second one. Second question, Darren buys a car for $35,000. The value of the car decreases by 15% in the first year. We have to find the value of the car at the end of first year. So value, we can use the formula. It will be P times 1 minus R to the power of N, right? The value was 35,000, which is the principal value, right? 1 minus R will give you the rate it will hold at the end of 1 year. So R would be 0.15 here, as it's 1 year, so N will be equal to 1. So if we simplify this, 35,000 times 0.85, we would get 29 $2,975. So this is the value of the car at the end of the first year. Now, after the first year, the value of the car decreases by 11% in each subsequent year. The thing is, for the first year, it will decrease by 15%. After that, it will keep decreasing by 11% every year. So we have two different percentages. First year, 15%. After that, every year it will decrease by 11%. Right, so we can use our, the depreciation formula. Now, in this case, we have to find the value of Darren's car 10 years after he buys it, right? So what I'll do here is, for the first year, I know that at the end of first year, the rate of the car or the value of the car will be 29750. And the rate of depreciation after the first year would be 11%. So what I can do is I can remove the first year, right? I can say that the initial value of the car is 29750, right? And it will keep decreasing by 11% for the next 9 years. So at the end, we'll get the same, the same value. So here, if we do it, principal would be the value at the end of the first year. R would be in this case 0.11, and the car will continue depreciating for the next 9 years, because 10 years total. First year you have considered by taking the principal value of 29750, and now you're trying to find the value at the end of 10 years, which is 9 years after the first year. So if we simplify this, is 29750 times 0.89 to the power of 9, which on simplification gives us 10423.1 US dollars. This will be the answer to part B. Now, Now for part C, when Darren has owned the car for n complete years, the value of the car is less than 10% of the original value. Find the least value of n. So this, I'll just add a new page here. So the value of the car should be less than 10%, right? So value, this should be less than 10% of the 35,000, which was the initial value. So value should be less than 3,500. Right? Now for the value, I can use this equation. This is the depreciation equation, right? So P 1 minus R to the power of n should be less than 3,500. Now again, I will exclude the first year, right? How will I exclude it? By taking the principal value as the price, or as the value of the car at the end of the first year. So I can take 29750, 1 minus 0.11 to the power of n as 3,500. So if I shift the 29750 on the other side, I'll get 0.89 to the power of n less than 3,500 divided by 29750. The value would be 0.11765, right? Now what I'll do is I'll take log on both sides. If I take log, what happens is I can take this power, it would be like log 0.89 to the power n, and I can move the power to the front. Can write it like this. Right? Now what happens is I'll divide both sides with log 0.89. So n would be greater than log 0.11765 divided by log 0.89. Now you might be thinking, why I changed the sign? Thing is, the log of 0.89 is actually a negative value, right? And if you are multiplying or dividing an inequality with a negative value, what happens is you have to flip the inequality sign. So that's why this inequality sign got flipped. So n would be greater than 18.36 if you simplify this. Now greater than 18.36 means n is approximately, it should be 19 years, right? So now other than 19 years, you should remember that we have chosen the principal value as 29750, right? So you have to add the first year to it, the final value of n, right? So total number of years, this will be 19 plus 1, which is 20 years. So after 20 years, the value of the car would be less than 10% of the current valuation. Okay, 10% of the initial valuation of the car. Right, so with this, we are done with this question. We can move on to the next one. Alright, so here we have a monument which is in the shape of a right cone with a vertical height of 20 meters, and there's a person, Oliver, who stands 5 meters from the base of the monument. His eye level is 1.8 meters above the ground, and the angle of elevation from Oliver's eye level to the vertex of the cone is 58 degrees. And I guess, we have to find the radius of the base of the cone. Okay, so let's take this as the radius. This will be the radius. Let's mark it with R. So this is your radius. We'll mark it with R here. Right? Okay. Now this height is 1.8. So this height would be 20 minus 1.8. Yeah. This would be 20 minus 1.8. because this entire height is 20 and this height is 1.8. So this height would be 20 minus 1.8, which will give me 18.2. Right? Now using this triangle, right, I can actually find the length of this base. So I can say tan 58 degrees, this will be perpendicular or opposite over base, right? So 18.2 is opposite and base is this one, right? Now this base, let's say this base is x for now, right? I'll just take it as x. So x. Now if I use a calculator, the value of x would be 18.2 divided by tan 58. So which on simplification would be 11.37. Right? So this total length is 11.37 and this total length will also be equal to r plus 5, because you can check here these two lengths are exactly same, right? So x and r plus 5 they should be equal. So r plus 5 should be equal to x. So r should be 11.37 minus 5. 11.37 minus 5, which is 6.37 meters. So this is the radius of the base of the cone. Now we have another part to it where we have to find the volume of the monument. To find the volume, you can use the volume of the cone, which is 1/3 pi r squared h. So 1 by 3 pi 6.37 whole squared. Height would be 20 meters, so 20 squared. No, just 20, sorry. Yeah. Now if I plug it in a calculator, I'll get 849.84. For the units, I have to check, okay, it's in meters, so the unit of this would be, it would be meter cubed. And this will be the answer to the second part of this question. So that was an easy 5 marks. And we can move on to the next question. So random variable x is normally distributed with a mean of 10 and standard deviation 2. When the probability that x is more than 1.5 standard deviation above the mean, right? So x is 1.5 times standard deviation above the mean. So mean plus 1.5 times the standard deviation, right? So 10 plus 3, which is 13. So we have to find the value of p of x greater than 13, right? So yeah, now to find this, we can use a calculator, right? You can use your calculator. So your mean would be 10 and standard deviation of sigma would be 2. Yeah. And now when we evaluate this value, we'll get this value as 0.0668, and this will be the answer to part A, right? So for this, you have to use the normal CDF function. The next one, probability that x is more than k standard deviation above the mean is 0.1. Find the value of k. So in this case, you have to use the inverse normal distribution. Basically, p of x greater than m, this is 0.1. Now you can use an inverse normal calculator. Your mean would be 10 and your standard deviation would be 2. If you use this inverse normal calculator, right, and if you do the right tail test, the value of m will be 12.5631. Right? So this is the value of m. Now it says that k standard deviation above the mean, right? So mean is 10 plus 2 times k. This should be equal to 12.5631. Yeah. So from here, if I simplify this, the value of k would be 1.282. So here, like probability of So moving on to question 5, here we have a particle which moves in a straight line, such that it passes through a fixed point O at time t equals 0. So t equals 0, it passes from here. The t represents time measured in seconds after passing O. So between 0 and 10, this graph has been plotted, and yeah, so this is the equation of velocity with respect to time, right? So we have to find the smallest value of t when the particle changes its direction. So what does this mean? Basically, whenever we say that the particle is changing its direction, basically the sign of your velocity will change. So particle changes direction when velocity changes its sign. So it says that you have to find the smallest value of t for which the particle changes its direction. So smallest value of t will have, it will occur here. So here velocity is negative, it will become positive. So we have to find the value of this point. How would we find it? So we can basically plot this equation in your calculator, and we can find the value of this t. In order to plot it, replace velocity with y and replace time with x. Now I'll do it on Desmos and I'll show it to you how it looks like. So yeah, so y equals 2, then we have sine 0.5x plus 0.3x minus 2. So this is our curve, and we can clearly see this is the first point, and this is the point, like this is the time we need. This is the point where the particle changes its velocity. So our time from the graph, value of t, this would be 1.687 seconds. This is the answer to part A. Now moving on to part B, the displacement of the particle is measured from O, and the range of values of t for which displacement of the particle is increasing. Now displacement of the particle will increase when the velocity is positive, and the velocity is positive between these two time intervals, right? So just like I'll go back to the curve, I'll find the time. So one is 1.687, other one is 6.119. So let's say displacement is increasing when the velocity is positive. Right. So from the graph we know that it starts becoming positive from 1.687 seconds, and it will start becoming negative from this value. Exactly. So you can say displacement is positive in the time interval between, like, which is less than 6.119 seconds, which is greater than 1.687 seconds. This will be the answer to part B. Moving on to part C. So we have to find the displacement of the particle relative to O when t equals 10. Alright. So we know that displacement is integral of velocity with respect to time. So first we'll do an indefinite integral. It's 2 dt. Yeah. So if I solve this integral, I'll get minus 2 cos 0.5t divided by 0.5. This will become 0.3 by 2 t squared, and minus 2 will become minus 2t, and we'll add a constant of integration. This is the equation of displacement with respect to time. Now I know that at t equals 0, your displacement would be 0. It's given in the question here. Yeah. So here it measures it after passing O, right? At 6.0, O is basically the origin in this case. Yeah. So yeah, so I know that at s of 0 would be equal to 0. So we plug in 0 in this equation. So 0 would be equal to minus 4 cos of 0.5 times 0 is 0, plus 0.15 times 0 squared, minus 2 times 0 plus c. So from this you'll get 0 equals minus 4 plus c. So c should be equal to 4, right? Quickly add a page here. Yeah. So your equation for displacement with respect to time would be minus 4 cos 0.5t plus 0.15 t squared minus 2t plus 4. Now we have to find the displacement at t equals 10 seconds. We have to find s of 10. Minus 4 cos 0.5 times 10 is 5 plus 0.15 10 squared is 100, or let me just keep it like this, and 2 times 10 is 20. Now if I simplify this, at the end I'll get minus 2.135 meters. This is the displacement at 10 seconds, and this will be the answer to the last part of this question. Yeah. Now let's move on to the next one. Yeah. So a class is given 2 tests, test A and test B. Each test is scored out of a total of 100 marks. The scores of students are given. Okay. So yeah, this is the test A data, this is the test B data. So yeah, x be the score of test A and y be the score on test B. So they have found the regression. Y is 0.82x plus 1.84. So first we have to find the Pearson product moment correlation coefficient for R. Now what happens is you have to use your calculator for part A, and yeah, okay, just do it here. So after you plug in the values properly, right, for x and y, at the end you should get the value of R as 0.901. This should come from your calculator. Moving on to the next part. Now teacher uses regression line of y on x to estimate the missing score. Paulo scored 10 on test A, right? So test A means this is the x value, right? And the teacher estimated that his score on test B should be 27. Now we have to give a reason why this method is not appropriate for Paulo. Now the thing is, if you look at the values, or I mean look at the scores of test A, you will see that 10 is like very far away from the lowest score. Lowest score in test A is 52, right? So 10 is like 5 times less than 52. Okay. So in this case, this 10 is an outlier, right? And as it's an outlier, we cannot use outlier data in our regression line. We can frame the answer in this way. The method is not appropriate for Paulo because his score on test A, which is 10, is an outlier and lies far outside. Let me add a page here. The range of scores used to derive the regression equation. Regression models are generally reliable within the range of data used to create them. But extrapolating beyond this range can lead to inaccurate and unreliable predictions. So this should be roughly our answer. As it's a 1 marker, you can maybe shorten this and write it in your own words. Moving on to part C. So we have another guy who scored 90 on test B. So this is the Y data, right? Because test A has been taken as X and test B would be taken as Y. The teacher estimated his score on test A to be 87 to the nearest integer using the following calculation, right? So see here, they are trying to find the value of X from the Y, Y on X regression equation. Yeah, this is not exactly valid. So first C1 would be give a reason why this method is not appropriate, right? So here what happens is this method will not be appropriate because regression equation predicts the value of Y based on the value of X. Yeah, in this equation what happens is we are using the value of Y to estimate X, and that does not check the variability of X when Y is given to you. Right, so we are essentially what we are doing is we are reversing the independent and the dependent variables, and as a result we can encounter a good number of error in this way. So writing it in my words, this method is not appropriate for money because the regression equation given predicts Y, which is the score of test B, based on which is the score of test A. Using this regression equation to estimate X based on Y is inappropriate as the regression equation does not account for the variability of X given Y. It is essentially reversing the roles of dependent and independent variables which can lead to significant error. This will be the answer to C1. Now we can move on to C2. Now we have to use an appropriate method to show that estimated test A score for Giovanni is 86 to the nearest integer. So in this case what happens is we have to create the regression equation such that your test A should be Y and test B should be X. Now if you use your calculator and generate this regression equation, you will get something like this. y equals 0.9871x minus 3.220. Here y is the score of test A, while x is the score of test B. This is the second part of question C2. Yeah. Now I know that his marks in test B is 90. So here, so in this case, the x value is 90. Now I'll use this value to predict the value of y. In this case, remember, y is your score of test A. If you simplify this, you'll get 85.62, and 85.62 can be rounded off to 86. Right? So hence, we can say that estimated test A score for Giovanni is 86, and we have successfully proved it. Right? So we have to prove that we have to use an appropriate method to show that the test A score is 86. Now we can move on to section B. Now moving on to question 7. So here we have a function fx is 3 by 2 e to the power of x minus 2, right? And the domain is given between 0 to 4. We have to show that inverse function f inverse x is 2 plus ln 2x by 3. So let's do the first part. You can just solve it here, right? So this function can be written like this. In order to find the inverse, what happens is we have to flip x and y, right? And then solve the equation in terms, convert the equation in terms of y. So I'll just flip x and y. So I'm just changing the position. I have to solve this equation in terms of y. So 2x by 3 e to the power of y minus 2. Now if I take ln on both sides, ln of 2x by 3 would be ln of e to the power of y minus 2, right? Now ln of 2x by 3, this thing, let's keep it like this, and e to the power y minus 2, I can bring this y minus 2 outside and we'll have ln e. Ln is log base e, so log base e, this thing will have a value of 1. Yeah. So if I simplify it a little bit, so we will get 2 plus ln 2x by 3, and in this case your y is f inverse x, so f inverse x would be 2 plus ln 2x over 3, and this is what we need to prove. Okay, now the next part. So graph of fx and f inverse x will intersect at the points p and q. So we have to find the distance between pq. So basically we have to find the points p and q. In order to do that, we can just find the points of intersection using our graphical approach. Right, so I'll just head on to Desmos, and yeah, here we have first function will be y equals 1.5 e to the power of it will be x minus 2. Okay, it will go in the numerator, so x minus 2. This is our first function. The inverse function is y equals 2 plus, then we'll have ln, you can find it here, ln 2x over 3. Yeah. Now these are the points. So point P is 0.264, 0.264, and Q is 2.518, 2.518. So point P is 0.264, 0.264, while point Q would be 2.518, 2.518. Yeah. To find the distance PQ, which will be x2 minus x1 whole square plus y2 minus y1 whole square. 2.518 minus 0.264 whole squared plus 2.518 minus 0.264 whole squared. Put it out. Now if I just quickly solve this, the answer will be 3.188, and this will be the answer to part B. Plain and simple. We can move on to the next part. So graph of f reflected in x-axis and then translated parallel to the y-axis by 5 units in the direction in the positive direction to give the graph of function g. So first we have to find the expression for gx, right? So first, when we are reflecting the function about x-axis, what happens is we have to do minus fx. So the equation will become minus 3 by 2 e to the power of x minus 2. Right, and then you're translating it 5 units in the positive direction of y, so plus 5, fx plus 5. of 5 units parallel to y-axis. This will be y equals, and this is your gx finally, minus 3 by 2 e to the power of x minus 2 plus 5. This is the equation of gx, and this is the answer to part 1 C1. Domain of g, in this case it's an exponential function, right? X is on top of an exponential function. So for an exponential function, you can plug in any number here and it will be valid. So from minus infinity to plus infinity, you can plug in any real number in the place of x and you'll get a valid value. And hence the domain of x in this case will be from minus infinity to plus infinity. Domain of g would be either you can say x belongs to R or this. Yeah. Now moving to part D. We can add a page here quickly. So solve the equation fx equals gx. Give your answer in the form x equals a plus ln b. So fx equals gx. So fx is 3 by 2 e to the power of x minus 2, and gx would be minus 3 by 2 e to the power of x minus 2 plus 5. Now shifting this to the other side, we'll have 3 by 2 e to the power of x minus 2 plus 3 by 2 e to the power of x minus 2. This will be equal to 5. So this can be written as 3 e to the power of x minus 2 equals 5. E to the power x minus 2 would be 5 over 3. Yeah. So if I take ln on both sides, ln of 5 by 3. So x minus 2 ln of e is 1, which will be ln of 5 by 3. So x would be 2 plus ln 5 over 3. Now as I remember, it was a plus ln b, something like this. A plus ln b, a and b really belongs to q. Alright, so with this we are done with this question and we can move on to the next one. So this question is, there are 2 islands in the Atlantic Ocean in the same time zone. Given the height of the water in Sulzberg is modeled by this equation. So we have one equation here, right? T is the number of hours after midnight, and is the height of the water. They're showing it for 15 hours. Sorry, where did it go? Yeah. So all heights are given to correct 2 decimal places. The length of time between first low tide and the first high tide is 6 hours and m minutes. Find the value of m, right? So here we are talking about this given wave, right? So time period will be how much for this wave? This will be 2 pi divided by the number multiplied to t, which is 0.513. So this on simplification will give me 12.247 hours. Now between a crest and trough we have half time period, like the time difference between a crest and trough would be t by 2, right? So here the length of time between first low and first high tide will be 12.247 divided by 2. Time difference between first low tide and first high tide, this will be equal to 12.247 divided by 2. So 12.247 divided by 2, it gives you 6.1235, right? Which is 6 hours and 0.1235 times 60 seconds. 60 minutes. So 0.1235 times 60, which is 7.41. So 6 hours and 7.41 minutes. Now here we have to round m to the nearest integer. So the nearest integer is 7. Therefore, your value of m would be equal to 7. This is the answer to part A of this question. Yeah, done. Now part B. Between 2 consecutive tides, determine the length of time for which height of water is less than 1 meter. So let's say this is 0.5 and this is approximately 3.76, right? So 1 meter would probably be somewhere here. This is 1 meter, right? So I have to find these two time intervals. This is T1 and T2. And if I do T2 minus T1, I'll find the total time where the tide is less than 1 meter. It says less than 1 meter, so I have to look for this time interval, because only in this time interval the wave height is less than 1 meter. So how to find that? I can again use our graphing calculator to solve it. So I'll just graph this equation, and then it will be easy for us. So ht would be y in this case, right? And time would be taken as t. So it is 1.63 sine 0.513 x, time is x now, minus 8.20 plus 2.13. Let me just check the equation once. Yeah, all right, this is fine. So okay, this is the equation, and I'll put in y equals 1. I got the time intervals, right? So I can just subtract them and get the total time. So in this case here T1 would be, T1 would be 3.576 hours, and T2 would be 6.713 hours. So delta T, right, this is the length of time, would be T2 minus T1. 576, which will be 3.137 hours. This is the answer to part B. Now moving on to part C, rate of change of height of water when t equals 13. So rate of change of height means we have to find h prime t or h dash t. So ht is 1.63 sine 0.513 t minus 8.20 plus 2.13. Now if I differentiate this, I'll get h prime t, which will be 1.63 times 0.513 cos of 0.513 t minus 8.20. Now we have to find h prime of 13, so I'll plug in 13 instead of t, which I'll get 0.836 cos of 0.513 13 minus 8.20. And if I plug this in a calculator, my final answer will be 0.65. Unit of height is in meter and the unit of time is in hour, so this will be my answer with the appropriate units. And this will be our answer to part C. Now moving on to the next one. So on the same day, the height of water in the second rocky island rockall can be modeled by the function ht equals a sine b t minus c plus d, right? So they have given us some information about the first low tide and the first high tide. We have to find the values of a, b, c, d. Okay. Now to find the amplitude would be the, you have to, this is basically your trough and crest. So you subtract them and divide by 2, you'll get the value of a. So a would be 2.74 maximum height minus minimum height divided by 2. This on simplification will give you 1.17, right? Now D is basically, if I draw a regular curve here, this is an approximate curve, right? And let's say this is your middle value, right? So this value is A, let's say this value is P and this value is Q. So this distance will be D, right? I know this distance is A. Yeah. So basically, if I add A with P, right, I should get the total value of D. So A plus the lower value 0.4. So that will give me 1.17 plus 0.4, which is 1.57. So I got the values of A and D. Now next, the time period, right? So first I'll find the time difference between the high and the low tides. So here they have given in minutes and hours. So you have to convert it to decimal of hours in this case, because T is in hours, right? So time difference between high and low tides, this will be, so time difference of this minus 41, right? So if I simplify this, it will be 6 hours and 21 minutes. Okay, which will be 6 plus 21 minutes can be converted to decimal by dividing it with 60, which will give me 6.35 hours. Now the time difference between a crest and trough is half the time period. So time period would be double of this time difference. Yeah. 2 times 6.35, 12.7. Now we have to find B. I know for time period the formula is 2 pi over B will be your time period T. So from here B would be 2 pi by 12.7. 2 pi by 12.7, this value will come out to be a 0.495. So we got the value of B, we got the value of A, and we got the value of D. Now just we have to find C, right? Okay. For C, we can choose any one of these two values and that should be enough. So how would we do it? Let's look at the smaller one, right? So this is your equation. I'll plug in all the known values inside and you can just solve for C. So yeah, so HT would be, okay, let's take the bigger one. There's no issue, we can take any one of them. 2.74, it will be 1.17, yeah, sine. Value of B is 0.495. Time, in this case, would be 9 hours and 2 minutes, right? So 2 minutes would be 2 divided by 60, which is 0.06, so 9.03 approximately. Minus C, plus your value of D would be 1.57. Yeah. So if I transfer 1.17 to the other side, I'll get this. This will also be 1.17. So 2.74 minus 1.57 will give you 1.17. The sine of 0.495. This is 1. This will be basically pi by 2, the first solution. So from here, if I solve for C, I'll get 5.857. This will be the value of C. So at the end, if I list out all the values, A was 1.17, B was 0.495, C is this 5.857, and your D would be 1.57. This will be your answer. So yeah, and this was 7 marks, so it was a pretty heavy question. Now the next part. Okay, so when time t equals t, capital T, the height of water at Suli is same as the height of the water at Rockall for the first time. So basically the heights are the same. So you have to find the value of t for which the heights would be the same for the first time. So basically again we can solve it with like graphing, right? So for the previous question, the height, if I use the values of A, B, C, D, so 1.17 sine of 0.495 t minus 5.857 is 1.57. And for the first curve, the equation was 1.63 sine 0.513 t minus 8.20 plus 2.13. Now if I just plot them, right, I'll get the time t. I just have to check the first point of intersection between these curves. So your ht heights will be represented, you can convert it to y, and time would be converted to x. Now moving on to our Desmos. So already plotted the second curve here. I just have to plot the first one, 1.417 sine of 0.495, done. X minus 5.857, right? 5.857 plus 1.57. If you do this, this will be the first point of intersection, which is 4.163. So they first intersect at t equals 4.163, and this will be your answer, 4.163 hours. Yes. Now moving on to the very last question. So here you have a setup. So basically this distance is 50, this is 25, and this is 28 degrees Celsius, right? So now we have to use our knowledge to find two possible sizes of this angle OAB. Okay. So what I'll do here is I'll use cosine formula to get the values of this side. Yeah. And then basically use sine formula to get this angle. So let's do A1 first. Let me add a page here. Let's say this thing is Z, right? This third side, unknown side, is Z. So basically cos 28 degrees would be 50 squared plus Z squared minus 25 squared would be twice 50 times Z. If I simplify it a bit, I'll get 88.3 Z equals 1875 plus Z squared. So Z squared minus 88.3 Z plus 1875. This should be equal to 0. Now if I solve this equation for Z using a calculator, I'll get Z as 52.77 meters, or I'll get Z as 35.53 meters. Let's say this is Z1, this is Z2, right? Now I'll use the sine formula. So sine. So for this, okay, let's say this angle is A. So we'll have to find two angles. So I'll use A1 and A2. A1 is for Z1 and A2 is for Z2. So I can say sine A1 by Z1. This will be equal to sine 28 by 25. So sine A by A equals sine B by C equals sine C by C. That's the sine formula. I'm using it here. So Z1 basically I can plug it in directly and solve. So it will be 52.77. So here if I solve it, the value of A1 would be 82.3 degrees. Right, I have to use a calculator. And in this case, sine of A2 divided by Z2 would be again sine 28 over 25. And instead of Z2, I can plug in the value and directly solve this equation. So your A2 in this case would be 17.65 degrees. So these are the possible answers to this part 1. So OAB can have two possible sizes, either 82.3 or 17.65. Either be 0.3 degrees or 17.65 degrees. Right? Now moving on to the next part. So we have to find the two possible areas for this triangular field. Now for area, we can use this formula, half AB sine C. Right? So yeah, I'll use this Z1 to solve. So area 1 half AB sine C, or basically I can use half Z times 50 times sine 28 basically. So I'll use Z1 sine yeah, you can use sine 28 degrees. In this case, if I place the value of Z1, I will get let me check. So 50 times 52.77 times sine 28, I'll get yeah, I'll get 619.36. Wait, what? 619.36 meters squared. Now to find area 2, we'll use half times Z2 times 50 times sine 28. Right? So if I use this, I'll get 189.5 meters squared. These two would be the answers to this part 2, A part 2. Right? And this was easy 8 marks, I feel. Now this is the last part of this question. So now what happens is they have attached this CD, right? So there's a fence CD which has a length of 10 meters and this angle is 28 degrees. Now they are saying that OC is X. So this thing is X and OD is Y, right? So, and they are saying that this triangle OCD has an area of 60. So we have to prove this statement first for part B, right? Now as the area is given, I can use the sine formula of area to get a relation. So it will be half XY sine 28 degrees. This will be equal to 60. So from here I can say sine 28 degrees would be 60 times 2 is 120, 120 by xy. So this is my first equation. Second, I can use the cosine formula. So cosine 28, this would be how much? This will be x squared plus y squared minus 10 squared divided by twice xy. So this is the value of cos 28. Now if I divide sine 28 with this cos 28, what happens? So basically dividing equation 1 by equation 2. Sorry for that. So 120 by xy. So dividing cos 28 means I can reverse and multiply the fraction. Twice xy divided by x square plus y square minus 100. Now if I simplify this, I'll get 240 divided by x square plus y square minus 100, and sine and cosine together I can say it's tan 28 degrees. Now here we have to prove x squared plus y squared. Okay, so I can shift these two. I can say this is 240 by tan 28. So finally x squared plus y squared 240 over tan 28 plus 100. And this is what we need to prove. So that's it for part B, and now we have to start with part C. So to determine two possible lengths of OC. For two possible lengths, basically we can use these two equations to solve for x, basically. It's a simultaneous solution. So for part C, x squared plus y squared, if I simplify this side, it will become 551.37. And for xy, it's 120 by sine 28. So if I do that 120 by sine 28, I'll get 255.61. Now we just have to solve these two simultaneous equations for the value of x. Now we can use our calculator, right? So if I use a calculator and solve for x, I'll get these values for x. For x, these are the values of x which you'll obtain. You'll get minus 13.13, you'll get plus 13.13, you will get 19.47, and you will get minus 19.47. Right? Now as here we are using lengths, so I'll ignore the negative values. Right? You can say as lengths can't be negative, we can say the only possible values of OC, which is x, is 13.13 and OC would be 19.47 meters. So these two would be the two possible values of OC, which is basically your x. Now with this, we are done with the paper, and I'll soon be posting the solutions of AISL paper 1 and paper 2. Thank you so much for watching this video. See you all again very soon.